Hello, BC students. So this video is actually, I'm filming this specifically to address part B. Okay, the reason I'm doing part B is because I think when I taught this, I think it was probably one of the more confusing parts, and I wasn't especially clear on how to, when we do revolutions around not the x-axis, so about like a line, in this case, y equals -2, how to do that best. So let's say I have this line, which is at -2 here, and I'm just estimating that, and I'm revolving this shape around y equals -2. Well, we know that we know here that we're going to do something called the washer method, right? So essentially what we're doing, like if you can imagine revolving this shape around y equals -2, you'd have like some sort of shape down here, right? And then you'd have each cross section looks like that. And then there's an inner radius or inner hole that looks like this. So you have a bigger outer radius. So you have the integral of the outer radius. So outer squared, and since we're making a circle, it's going to be pi r squared. So it's going to be, pi r squared, and the radius is going to be the outer function. Then I'm going to subtract the integral, pi times the integral of the inner function squared, right? So I'm taking this outer radius and I'm subtracting the inner radius. That's why the inner part is blank, because I'm subtracting that part. Okay, so this is our washer method, right? So our washer method is pi times the integral of the outer square minus inner square. And that's fine. That makes sense to us. Hopefully you understand this conceptually. But the question is, how do I write this outer function? How do I write this outer function, right? When it's not revolved around the x-axis, it's revolved around a different axis. So I need to adjust my equation to accommodate for that. Well, let's see here. So when I revolve r around -2, what is my outer function? Well, my outer function is clearly going to be this function, right? It's the one that's outer, has a bigger radius when I revolve it, right? It goes from here to here. Whereas this function, I'll mark this in green actually, that's my inner function, right? It goes from here to there. You can imagine when I revolve around it, it has a smaller radius. Okay, well, how do I write this outer function? Well, the way to write this outer function is actually simply to find the equation of this function, essentially in relation to the axis of revolution, in relation to -2. So how do I find this length? How do I find this relationship, the difference? Well, it's simply going to be, if you could almost imagine, it's kind of like the upper minus lower. What is that distance? The distance is going to be this upper function, which is y equals x e to the x squared, right? So it's going to be x e to the x squared. And then what is the distance between this function and this function? Well, I'm just going to subtract the bottom function. So I'm going to subtract -2. So this tells me my outer radius has an equation of x e to the x squared plus 2. So it's going to be x e to the x squared plus 2 squared. Now I'm going to subtract my inner function. Well, what is my inner function? My inner function first is y is equal to, what is that? -2x. Right? Okay, so what is the distance? What is this radius distance? What is the distance between -2x and -2? Well, I'm simply going to subtract the 2 to find this distance. So it's going to be -2x minus -2, right? So -2x minus -2, right? That will give me the difference between the two, and thus the distance between the two. So that's going to be equal to -2x plus 2. So that's going to be my inner radius. So -2x plus 2 squared dx. And there's my answer for part B. So hopefully that helps. Bye, everyone.